We're setting up today a complete home-based AI server. And this is going to be simpler than the guides we've put together in the past, and it's going to work on any class of a system. Whether it would be a quad rig system with tons of GPUs and tons of horsepower, to a single card GPU system, this is going to be applicable to all of them, and it's going to work exactly the same. Good news also, it's easy to back up and restore in case you have an issue, which I'm going to show you all of those steps today. You can also check out the website article that gives you copy-paste friendly scripts for you to get this set up and running. And be sure to hit like and subscribe while you're down in the description below where you can find the chapters. And if you want to skip around to any part of this, feel free to use those at any time. Let's get started. The rig that I'm going to be demonstrating off today will have 4 GPUs attached, but I will show you also if you have a single GPU, what you would need to do. And you can see we have risers, we've got a rack frame, and our 4 3090s that I repadded. We also have tons of cooling, 512 gigabytes of RAM, and 2 512 gigabyte NVMEs that we're going to put in a RAID 1, so we have redundancy. Cooling our CPU with a 420 millimeter. And we also get to use some really cool things because this is a server class motherboard, the MZ32AR0, such as the BMC, which allows us to have really easy connectivity. And of course, you can check out that full video. One of the nice things about using server class hardware is that you do get amazing capabilities like BMC, which allows you to remote in without actually having to have a monitor display connected to it. Of course, you could just have a monitor, keyboard, and mouse plugged in and accomplish the same things. So we'll enter the setup, and this will allow us to change a couple of settings in BIOS that will ensure that we have a very straightforward and easy way to understand what's going on in case we do run into any sort of problems. So trusted computing is completely disabled. CPU configuration, SVM, which is for virtualization, is enabled. And we have our boot mode set to legacy. And we have our 2 NVMEs connected as boot options 1 and 2 for our hard drive. Once you've made those changes, which may differ in your setup, but should be kind of named somewhere around the same, go ahead and save and reboot. Go ahead to the Proxmox.com website, click on download, and grab the 8.3 or whatever the most current version is. This will provide us with the virtualization that we need to be able to set up our LXC-based container, and this container will allow us to run not just our AI workloads, but so many other workloads on the same machine incredibly efficiently, all while sharing very valuable resources like GPUs that are quite expensive. And you can use Rufus.ie to burn this if you are on Windows. As well, you could also, if you are on Mac or Linux, use Balena Etcher, and these are capable of writing the ISO to the USB. So just go ahead, do that. Next, we're going to enter the BIOS boot menu and select the USB drive. And we'll press F10 to enter the boot menu and select our flash drive. Select the graphical installation. Go ahead and click agree, then select options. We're going to use on this system a RAID 1 setup so that we have redundancy, and it's automatically going to select our 2 drives here. And if you go to advanced options, I would recommend always backing it off at least a little bit, just in case you run out of hard drive space. You'll be able to do an emergency expansion of it in a secondary system and be able to at least reboot. Go ahead and click OK and click next. Select your time zone, country, enter a password and a valid email address. You'll get information sent to this email address. From the drop-down of your management interfaces, you should select the interface that has a green dot next to it, which means that it is connected. And that's going to be one of our onboard 1 gigabit connections right now. And give it a IP address that will be for the management interface. This is where you're going to go to log into the Proxmox system. And go ahead and click next. Click install, and it will go ahead and install your Proxmox operating system. Very few steps, and it will be done pretty darn quick. And once you see this screen presented, you can go back to your normal client and access it at the IP address that's listed with the port number 8006. Do note, this is HTTPS with a self-signed certificate. So when you first reach your website, go ahead and hit Advanced and Proceed. Enter in the credentials that you used when you set up the system. Go ahead and click OK on the subscription nag. Once you're logged in, go ahead and select the host that we just installed. Now, you'll note that there's a data center up here, and you might be wondering what that is. You can do some cool things like set storage. So if you have something like a NAS, you can add an SMB or a CIFS or an NFS share, and that'll allow you to access shared storage. Really great if you have multiple models. We'll get into that in a future video. Underneath that, you can see that we've got Prox0. The first thing that you want to do is go to your repositories and click Add. From the drop down, go ahead and select No Subscription. And from the lists here, you'll see a Ceph and a PVE Enterprise. Select those and click Disable. Now you can go over to Updates here and hit Refresh. Click OK. It's going to pull some information about which things need to be updated on your system. Go ahead and close that, and you'll see a lot of files presented here that are going to be updated. And we're going to go ahead and click Update. And go ahead and click Yes. It's good to note, just for your own information, that this is based off of a Debian system. So you're going to find that most of the things that will work on Debian are going to work on Proxmox. That should be used with some level of caution, however. Close that window and click on Reboot with the host selected over here, and that will reboot the entire machine. Next, once you're rebooted, go ahead, open up a new shell in your Prox0, and we're going to go ahead and install some additional software that's needed to install the NVIDIA proprietary driver. And this will take a bit of time, so this will not be super quick. Next, we're going to go ahead and grab our NVIDIA driver. Just go to nvidia.com and go to drivers. You can just scroll right down to Linux drivers and go to their archive. And we're going to grab the 570. Hover over download, right click, copy clean link, and then we'll come back to our shell, type wget, and paste in the link. This will pull down a copy of the installable file, and we now have everything installed that we need to make this installation pretty quick. So next, do ls, and you'll see that you have your NVIDIA driver. Do chmod + x, and you can just do nv and star. That'll find that file and give us execution permissions. Next, type /nv and star, hit space, --dkms. Select NVIDIA proprietary. Go ahead and create the mod probe files, and it's a good idea to abort and to reboot after you click Rebuild Interim File System. It's going to tell you installation failed, but that's just the overall installation, not the particular task that we were after it to do. Go ahead and type reboot now. Next, once you're rebooted, go ahead, open up a new shell in your Prox0, and we're going to go ahead and install some additional software that's needed to install the NVIDIA proprietary drivers. The proprietary drivers will give you a little bit of extra performance over what you might get out of a baseline Debian installation. Go ahead and type reboot now. All right, now that you're rebooted, go ahead, open up another shell, come back, and we're going to just press the up arrow and rerun the installer. And this time it's going to complete, and that's pretty much the big parts of what we have to do here. And don't worry about the notification about the X library path. That's for if you have a graphical user interface. And since we don't have an X configuration, go ahead and click No, and it is done. Now, if you type nvtop, you'll see that our 4 GPUs are displayed. And if you followed everything in this order, when you do the next header update, things will continue working for you. The next thing that we're going to do is we're going to use the Proxmox VE helper scripts website, which you can find here, and we're going to use the Openwebui LXC. LXC container packages are also really nice because they can move around different systems. So like a TrueNAS system will be able to, in the future, run an Incus. You can run this on bare metal. And of course, in Proxmox, native support for LXCs as a first class. So we're going to come back over to our window, paste in the bash script here. And I did go through and look at this. if you want to, you can definitely follow the sources and read and review these yourself. I like to disable the diagnostics because I'm privacy focused. Go to advanced. And next we will just kind of go through most of this. We're going to give it a root password. This is why we picked advanced, because you want to be able to root password log into the system later. The container ID can stay the same. And the size is at 16 gigabytes. So this is going to be an all-in-one package that also has Ollama installed inside of it, which you can and will need to grow the size as you grow the number of LLMs or the size of the LLMs that you're running. Of course, also the same will be adjusted later on if you want to run more CPU cores. So this is absolutely capable of running something like DeepSeek 671B if you've got enough RAM and resources. And if you have an Epic machine, you can probably get pretty decent time on it. I'm going to go ahead and on this system, give it 8192. 4096 is also okay. The bridge should stay as VMBR0. That's your default. And I put most of my AI stuff in 192.168.1.6 range. So I'll just leave it there and /24. And the gateway IP address is usually, the rest of this you can leave like that. I'm going to disable IPv6 because it doesn't work on my network. And there we go. And I'm going to give myself SSH also. Enable verbose mode, and you are ready to go. This will take quite some time for it to get done installing. Next, we're going to hit yes and go ahead and install Ollama. Now, this puts Ollama in the LXC versus the prior guides, which had it in a separate container, but that was, of course, a Docker container, all of that living inside the same LXC technically. But this will allow you to easily have this up and running. This doesn't mean that the prior way doesn't still work or that you couldn't set up 2 LXCs if you wanted to. And I'll show you where you could make a change to adjust the actual address that you would be pulling your Ollama from if you're interested in going down that route. This does, though, give you a really quick way to get up and running with your installation. And just that fast, we have our new Ollama and Openwebui system up and running. So going to the address here, just go ahead and click on Get Started, and you need to create a username and enter in your email and password. And this is an administrator account. It'll let you know which version you're on. So this is the current version that we've got here. And a real quick overview, since some things have changed since the last time we took a look at this interface. We're going to start by going to settings, and settings has kind of 2 places where settings happens, which is a little bit confusing. So you can look at this as a settings that is fairly common to all the users. And you can look at this as a setting that is basically for you as an administrator. So if you go to models here really quick, you'll see that we have none listed. If you go to evaluations, this is the arena. You may want to turn this off. I don't really leave that on myself. The important one here is connections. We're going to turn that off since we're locally hosting only. And you see Ollama API. This we're going to leave enabled. And you see that it's connected to the address 0.0.0.0:11434. So this is where we would be downloading models. Now, slightly different since the prior videos that I've released is how you get there. So by clicking the little arrow there and coming over to this window, you can then jump over to the Ollama website by clicking the button for click here. And if we go to newest, we could see that there is XO1 Deep, which has gotten some pretty decent reviews, but not terrible amount of pulls. Unfortunately, a commercial license. Really wish people would stop doing that. And we're going to pull down a Gemma 3 here. So we can just take the Gemma 3. We're going to go with the 1B, copy that over and pop it in here and hit download. This will download really quick because it's a very small model. Also, don't think that you can't be running local AI without a GPU. I'm going to show you right now, we can run a local AI. This 1B model will run actually pretty fast. It looks like it's almost done. All right. The next thing that you want to do, though, before you get to running models is come over to the model page. You can now see the Gemma 3 1B is shown here, and click the little pencil icon. And under advanced parameters, you can change some settings. You want to try to match these to what I show in the videos when I'm doing the reviews. But in this instance, we're going to change the context length to, for our intents and purposes, let's say 32,768 is totally enough, because that really is totally enough. Make sure you hit save and update. That adjusts that permanently on this model whenever you run it. Now, if you look at web search, code execution, these things are definitely something we'll get more into, especially the code execution. There's been some new developments there. The web search, you can go back and watch the video that I produced on using Asir XNG for setting that up. It's definitely something that you should do because it will greatly improve your ability to get really good results. As well, coming over to functions, you can see that there is tons of functions that are available over on the Openwebui community. Now, these are pretty cool and they can give you a lot of additional capabilities that you may not have elsewise. So definitely take a chance to check this out whenever you get an opportunity. But we're going to go ahead and come over to the chat and just give it a quick howdy here. And we'll see what kind of tokens per second we can get on just the CPU. And so you see that we hit 31.37 tokens per second, and this is on just the CPU alone. Pretty impressive. And if you come over to your Proxmox instance and you click down into your Openwebui LXC container that we've got right here, you can come over to console, go ahead, log in with the same credentials that you did when you set it up, and you can type Ollama PS, and this will tell you that it's running 100% on CPU. So pretty freaking awesome that you can run small models on just a CPU. And of course, an Epic has massive amounts of bandwidth. So this is why running things like the DeepSeek 671B, which of course you can check that out in the history, and that was done on this exact same rig, is a very viable option. So we're going to go ahead and do a couple things that I think are good for housekeeping here. First off, we're going to take a backup, and it's not a bad idea to give it a few notes. So guest name, and I'm just going to give it a hyphen here, and before GPU driver install. For the storage location, we've got local selected, and we got quite a bit of space here. Also give you the ability to restore very fast if you have a problem. And once you've got that backed up, if you did want to restore from it, you could just click on this and click restore and select the target location, which of course local ZFS is our storage pool that we would restore to. And that would be it. Hit restore and you would be good to go. We're not going to do that though, because ours is functioning perfectly and we now have a backup of it. So in case we screw something up, always a good idea if you think you might be doing something that could screw something up to take a snapshot. Usually that's something like installing functions, tools, or especially if you're operating in the CLI and you have no idea what you're doing down there, that is a great time to take a backup. So we're going to come back over here real quick, and I'm going to show you one of the problems that we had in the past that we're going to address here. So of course, like I mentioned, in VTOP, able to execute and show the GPUs here. However, if we come over here and do an apt install in VTOP, because it's not installed automatically, and then we run in VTOP, it's going to tell us that there's no GPUs to monitor. And the reason why is because we have to take a couple of steps to pass them through. In addition, we also need to send the driver into this LXC container. So coming over to our host, we can do a ls, and we see that we've got our NVIDIA driver here. This time we're going to highlight it, copy that, and we're going to do a PCT push the container ID, which here is 100. So 100 here, 100 here. And the file name, since we're in the same directory, we can just paste that in and that'll look just like that. And then what we're going to push it into the container as. And so the folder is root that you are by default logging into inside your LXC. And we're also going to give it the name of the file. Next, we can do PCT enter 100. And this will now push us over into the container as well. And so hitting ls now, you can see that we've got the file in here. Next thing we need to do is chmod plus x and nv. And now we can go ahead and run it with this command, and we need to append no kernel modules to that. Go ahead, select the same that we did before. It's going to let you know that you're doing it with no kernel modules, and it'll then install. Now, if we hit NVTop, you'll see that we still have no GPU to monitor shown here. The reason why is that we have to physically pass through the actual devices into there. So we're going to come over here, and I'm going to show you how to do that. So we can type exit, and we are now back in prox 0 instead of in our container. You'll note that that looks different there. That's where we changed. So we're going to do a ls LA, and we're going to do dev NVIDIA and a asterisk. And this is going to give us our paths. Now, one thing that's important to remember here is that this path actually is a little bit different than this path up here. Go ahead and copy this first one. Now, if you have one GPU, you should have just 0 displayed. You would not have 1, 2, and 3, but the rest of this should be displayed. So come on over to our Openwebui container, go to Resources, click Add, Pass-Through Device, and paste in the device. Click on Add, and we're going to do that for the rest of our GPUs. That's 1, 2, and 3. Next, come back over to our console over here, and we're going to press the up arrow so we can get this again, and we're going to select this. Come back over to our resources, add this as a device pass-through also. And we're going to do that for the remainder of these also. Now for this one, you're going to grab this first because this is actually a slightly different path than just the dev /. So we need that -caps included, and then we'll have NVIDIA -cap1 and NVIDIA -cap2. So we'll go ahead and add these. Now we're going to go ahead and shut down our LXC container. And when it turns off, you'll see it in a stopped status. Go ahead and hit start again here. And since we have already instantiated at the host level, because we have done the NVTop a couple of times here at the host level to display the GPUs, they will show up automatically here. So go ahead, log in, and NVTop. So right there, you've got the GPUs passed through to your LXC container. Pro tip, those exact steps can get the GPUs passed through to all of your LXC containers, and you can have multiple LXC containers have multiple GPUs at the same time, including the same GPUs. However, sometimes you do want to have certain GPUs dedicated if you're doing something like a really heavy, long-running OCR task. So keeping in mind, you might want to partition those out a little bit differently and not just carte blanche assign them all to one device at the same time. However, it will not work if we reboot the device. So we're going to reboot the host here, and then I'll display what kind of a problem we're going to solve with something that is, there's two ways to solve it. We're going to solve it the kind of low-tech way, but it's actually significantly easier, and the end result is it works, and it will continue working. So I call that a win. There is another much more technical way of going about solving it. You can read more about that on the website. So you see that we've got an issue here. It'll tell us things like NVIDIA control does not exist when we try to start it up, or that NVIDIA device 1 does not exist when we try to start it up. So the way to overcome this is to have a script fired off here that will already run NVTop. So as soon as you run NVTop or NVIDIA SMI, both are going to instantiate the GPUs and access them and essentially trigger them to be visible. So the way to do this is to basically create a cron, and that cron is going to fire every time we boot up our device. We're going to just type cron tab -e. This is basically telling us to edit it. Just create a space there at the top, and then reboot space NVIDIA-SMI. So this will fire NVIDIA SMI at reboot every time on the host system, and that'll allow that to happen before the Openwebui container starts up, and that will allow it to see the NVIDIA GPUs. There are a lot of complex ways to do this. This is the absolute simplest, and the end result is the same. So if I go ahead and reboot now, when we come back, this will already start up, and it should have access to the NVIDIA GPUs versus being stalled out and of course having a crash condition, which is what we saw before. All right, now when we log in here, we can see that it correctly automatically started and did not crash out. By typing NVTop, we can see that they are visible. Perfect. And that is going to greatly speed up our ability to have fast conversations with local LLMs. Hitting refresh on that, you can see that's nearly instantaneous, 114 tokens per second, and that is exactly what it should be for this class of a system for this small of a model. Of course, this allows us also to go much, much larger, so you would not be running a 1B model with this. You would be running instead like the top of the line Gemma, which of course is the 27B, and with a big context window at that. And you can validate that it is running fully also in GPU, or see what the automatic split is by typing Ollama PS. And you'll see here that it is 100% GPU. If it does shard between the GPU and the CPU, it'll let you know here. If you wanted to adjust your resources, you can do that from over here. As you grow the number of models inside your Openwebui, you will want to grow the size of your actual disk. And to do that, come to your root disk and you can click on volume, actions, and resize. Now, easy to grow, very hard to shrink. So don't just go crazy with this if you don't have tons of space, of course. But if you wanted to add, say, 20 gigabytes to this, you can just enter 20, click OK. There's nothing else to do. It automatically has resized that now inside your console. So if you were to type df space h, you'll see that you have a full 26 gigabytes available now with 11 gigabytes used. So if you are running into a problem with downloading, keep in mind you probably need to resize this periodically here every now and then. Also, you may not want to keep every single model hoarded that you've ever tried out, as you are likely to find that some become obsolete faster, and you probably want to change those out. And you could increase your memory. And of course, we've got uber duper cores, so we could go way high here. But for the intents and purposes of demonstrating how to get this set up and running on any class of a system, this is perfect. So there you've got it. A really fast way to get up running with a really good, competent system that is very powerful and gives you a ton of capabilities. Check these out also, by the way, being able to have interactive calls. Yeah, you can do that for sure with Openwebui and Ollama. Of course, be sure to check out all the videos that we've done in the past where we covered things like putting together the Quad 3090 rig. As well, there is also, in my opinion, probably one of the best bets right now for people that are looking to get started, and possibly a good recommendation for you, using the 12 gigabyte $350 build. That is a really cool video. That is a very good system, and it gives you a lot of capabilities with 12 gigabytes of VRAM. Of course, you could get two 3060 12 gigabyte cards and have 24 gigabytes of effective space. Now, remember, for inference, it does not matter what the PCIe bus kind of speed is. It's not going to use a lot of the PCIe bus to transfer information back and forth. If you are training or if you are doing image generation, those are much more intense. And so those things definitely you would want to have high performance a GPU as you can get, and as high performance a negotiated rate as you would be able to get. And of course, This gives you the capabilities of doing things like you'll see in the channel history with even 12GB GPUs, like doing video generation and image generation with things like Pinocchio.computer. And also you could use cool stuff like WAN 2.1 for video generation. Take a moment and leave me your feedback down below. Let me know what you think after you get this set up and running. Let me know if you run into any issues and I will try to help you out as well. So I showed you how to build a system today that can work for any class, big, small, and everything in between. You could even take this to micro sizes. And while we did focus on NVIDIA specifically, there are good reasons for this. NVIDIA is still the cream of the crop when it comes to machine learning and to applied AI being able to handle multiple different types of workloads. You want to be able to do video generation, image generation, and also have a good chat experience. NVIDIA is still the way to go. There are interesting developments with some of the competition, but as of yet, it still lags well behind where NVIDIA is at. So I hope you've had a great time watching this today, and I hope that you can use this, and do feel free to check out digitalspaceport.com where we have the complete written article, and also a huge shout out to our members. Thank you for subscribing, thank you for buying coffees, and thank you for being Patreons. It makes this channel possible. Everybody have a great day. I'll check you out next time.